Welcome to the new video. Today we are going to see how to build an end-to-end data science project using cloud platforms. Yes, today we are going to use AWS SageMaker to build our end-to-end ML pipeline, and we'll see how you build model in your local, right? How you can take that into a production environment. Before jumping onto that, it's important for you to understand how the cloud platforms differ from traditional the instances that you use in your local, right? So the cloud platform, you can think of it's like a server or services that are running uh, on someone else infrastructure, right? And then you just pay to use the service that you are using. So we have different cloud providers, including AWS, Microsoft, and Google Cloud Platform. And then we have some other cloud providers as well, including Oracle, Alibaba, and there are plenty of others cloud platforms or the providers, but then these are the big players out there, and most of the organizations use these cloud platforms to build, scale their applications, their backend, their machine learning and AI services. So in this video, what we are going to use, we are going to use AWS. AWS Cloud provide you a lot of different services to build end-to-end solutions, whether it's for storing data, it provides you compute, it provides you database, it provides you analytics platforms, even for your networking, mobile developer tools, management tools for building IoT solutions to enterprise applications, for even AI, ML, even generative AI solutions. It provides tons of services for you, right? In today's video, we are going to focus on AWS SageMaker. Yes, Amazon SageMaker AI is a end-to-end platform that helps you to build, train, and deploy ML models, even including your generative AI and bigger foundation models. That's what they call as foundation models, but these are open source and even paid ML models that are present, where you can just use them without even managing underlying infrastructure. And that's the good part, is the self-serve, so you don't have to manage the infrastructure. You just need to configure it and then pay based on what you are building. Why SageMaker AI? Because as we have discussed, right, like you don't have to manage the infrastructure. Also, it provides you the low cost ML solution building, different tools for your end-to-end solution building, and also an easy integration with other services that or projects that you might be using. It has a lot of different ML tools, fully managed and scalable infrastructure, repeatable and responsible ML flows, also access to the human in the loop for even your data labeling work, model evaluation, and last but not the least, the generative AI assistance is there. You will see the pricing part, like how much pricing is there for any of the services. But for getting started, we are going to use the free tier SageMaker AWS account for getting started. If you go to AWS SageMaker, you can log in, you can create your free account. And if you click on this, I already have created an account, so you go through this part. Once you go to the sign part, this is how your dashboard will look like. Here, you can choose which region you want to work on it, what services you want to use. I have created a free account and I've used this. You can see that you get $100 as a credit for 6 months approx. And what are the services you are going to use? Accordingly, you will be charged. Few of the services that are present in AWS is this, where it has extensive list of services from end-to-end solutions for even for database, for cloud computing, for even building end-to-end web apps, mobile games, or even for IoT, machine learning. For our ML use cases which we are going to work, we are going to use Amazon SageMaker AI. Yes. Amazon SageMaker AI is again a platform you can think which provides you end-to-end ML building, deployment, maintainability, and evaluation of your model, right? There are different services that they provide, from governance to data labeling, for your processing job, for your model training, for your inference, and even for any models or services that are present in AWS SageMaker outside of AWS, all that you can get. To getting started, what you have to do, you just come here and create a domain. Like I have created few domains that we are using for today's demo. If you come here, click on this create domain, you will get a quick setup kind of thing right here. Just click on it and click on setup. I already have it, so I'm not going to create one more. And once you go inside it, you will see plenty of things that are already running, like what is the S3 bucket, what is the storage, and other things that are present here. Even if you go to the user profile, you will see a default profile is being created. And once you click on this, right, it provides you bunch of apps. And the most useful one that we are going to use today is our SageMaker Studio. Click on that and you will be redirected towards your SageMaker Studio, which again have bunch of apps. And the most common one is this JupyterLab that we are going to use today. And you can see here, this is going to exactly look like how your JupyterLab that you run in your local. There are a bunch of services that are present in terms of your compute, the data part, different jobs that you're going to run, deployment if you have an endpoint. All of these services are available here. Now we can see our domain has started up, right? And let's go into the domain and click on this user profile, and you can see a new user profile has been created, default one. If you want to create your own specific profile or any other name, you can do that. For now, I'm just using this profile that has been created by default, and I'll click on launch, and you can see now there are a lot of apps that are present. We'll go to the SageMaker Studio, and if you'll click on this, it will open the Studio lab for you, which is going to be a Jupyter notebook space, Jupyter space that is present. Apart from that, there are other services that is present. If when the first time you're coming, you can actually have a very quick tour. It will tell you different services that is present. So different features that are present in SageMaker that has, if you go to the experiments, you can see there are different experiments that will be present. You can launch and configure your applications through this UI. There are 5 applications that is available. If you configure more, you'll find more applications will be present. If you want to go back, you can just navigate back using this window, and yeah, that's what they're looking at the feedback. So that's pretty much. Let's get started. So these are the sample notebooks that are there. If you'll click on it, you will find some of the basic notebooks that is present. How to run a very quick start guide for running your SageMaker training, code locally, run on SageMaker kind of example that is present, right? So if you click on this, you can see you can get a very simple notebook. There is no space that is available. I can create a new space that is there. I can create a test space. So it will create a space and open a notebook. So the sample notebook that is present, it will open it. I've clicked on it. Let's wait for a few minutes and let it come. So you can test is starting. It may take up to 5 minutes to open, right? That's so initial setup takes time. And you can see here, if I'll go to the JupyterLab, I can see I have started a new space, which is part of your JupyterLab application, right? And it is starting up. If you click on it, you can see each space has its own storage, some of the settings that is there, the instance type, right? If you have any specific image that you want to pull, that also you can define. If I'll come back, you can see here, like, some quick start setup is also there. So I have started in another space, which is like a quick start default one. Both are starting at the same time. It will take few minutes. Let it run. And once the setup, the space is started, then we can click on it and get into the machine. Meanwhile, I can show you what are the different features that are present under this. So you have the home. Home is the same thing where you can pick and choose different services, models, and services that are present. This is the running instance. You can see I have started 2 instances. So one is in running state. You can see right now another one still starting. This is the data. So you can actually get the data. You can build your own data pipelines. You can connect data to some feature stores. You can even spin up some EMR clusters. This is AutoML. So you can actually, without coding explicitly, you can build a lot of ML models using AutoML. We'll not go into this in today's video, but this can be explored separately. What are the models and experiments that we are going to run, right? All will come under this. And this also comes part of your tracking server. So we'll create our MLflow experiment and we'll start the tracking as well. Different jobs as we have talked about, right? Like for training, for model evaluation, for performance evaluation, right? Like a lot of different kind of jobs can be created and you will find all of this here. Then you will have pipelines that has been built and you can run batch mode, or you can build pipelines that can have ETL, model training to model inference, like in complex pipeline. All that can be built here. All the models that you are going to build, right? All the different kind of models will be present here. So you can register your model, create different versions of your model like that. And last is the deployment. Let's say if you have to create a endpoint model inference, you can use SageMaker endpoints to do that. So let's go back and let's start our quick default server that we have just started off and see what we have there. And you can see now it has opened up a simple Jupyter hub, exactly the same which you have in your local. Like if you are running a Jupyter hub, JupyterLab, you will see a similar space. But now you can see this SageMaker JupyterLab is running on the SageMaker. And by default, a folder has been created here. And this was a quick start guide, like, a quick one. I'll open another space that we have also created. If you click on this, you can see this should have a sample notebook as well that we have picked up from the sample. Now you can see you have 2 different notebooks and you can exactly see these are different instances that are running. Like if you click on this, you can see there is an MLT3 medium instance is running. Similarly here as well, and another MLT3 medium instance is running. If anytime you're not using, you can just click and stop this server and keep it as it is, so you don't have to, worry about. Okay. Yeah, both the servers are running exactly the same. We don't have anything much to look into. If you'll come back, if you look, let's say you have this notebook, like open it and pick which one you want to. Let's just say I have used my test one. I'll open the sample notebook in that. What I can do is I'm not going to use it. I can just stop this one. So it will not take any compute because everything will get billed, right? Accordingly, how much is your utilization. So if you're not using anything, just stop the server. And I'm opening this sample notebook in my test workspace. And you can see here, like I have got a notebook, which is a sample notebook that is there. It is loading some data. It is running a few things that are there. This is a very simple notebook, but I don't recommend right now to go into this because we have our own demo and repo. That's what we are going to use for our use case. So this is a demo notebook. If anyone wants, this is I think small LLM that is there. That's what they're trying, and it will probably use GPU system. What we are going to build today in our demo today, we are going to use some simple machine learning model which you can deploy in SageMaker, and you can build your end-to-end data science project without you worrying about how to without worrying about how to manage things, how to create endpoint, how to deploy it, everything. We're going to do it in a simple way. So for our demo today, we are going to use this notebook, Customer Churn AWS M. What we have here is our very famous example that is there for customer churn prediction. So we are going to build an ML model and then we are going to deploy it on the SageMaker. This is a repo. You can go through this repo to understand what this project is all about, how to do experimental tracking, how we are going to do the SageMaker integration, how we are going to build ML model and then deploy it. Everything is kind of self-explanatory. You can go through the README. What I'm going to do right now, I'm going to take this repo and I'm going to pull this code in my SageMaker. Well, SageMaker provides you the GitHub integration. By default, if you just log in into the SageMaker, then you can just do pull, push, all the commit, or other operation. This repo is present publicly, so any public repo, you can even clone it, right? And you can get it. So I'll just put this and I'll clone this repo. And you'll see it will take some time and it will clone this repo and the whole code will be available for me here. Exactly, I can see here, right? Like I got this code in my SageMaker. It is as simple as that. Now I'll walk you through what each components that we have here. If you look into this, I have this ML experiment, a very simple machine learning experiment. So we'll go through this. That's how you generally do, right? You spend some time in initially data cleanup, data pre-processing, trying out different experiments that you want to try out for your model building. And then you figure out, okay, this is the best model that I have, and then probably choose that model and put it into production, right? Like that. Also, we're going to use MLflow. That is the experiment tracking thing that we have talked about, right? When you're going to run different experiments, mostly what happens, like you are not able to track it, different experiments, logging every artifact and everything that you have tried out, and running everything inside a notebook is not a reproducible thing. Like if tomorrow, if you want to go back and revisit, if something has changed in that notebook, everything is gone. And it's not a very fair way of comparing different experiments, right? Like, so that's what we are going to use MLflow for. So these two notebooks we are going to run for our experiments. Once we finalize our model, right, what we are going to do, we are going to jump onto the SageMaker and we are going to run this SageMaker end-to-end pipeline, where we have a specific training code, where we have specific inference code to first train our model using training pipelines, training jobs, and then deploy our model into SageMaker endpoint. So anyone can call an API to get the response. Also, there are some IAM policies that are there, right? Like if we to enable a lot of things, we have few policies. So that policies are available and we are going to use those policies. So I'll walk you through that when we are going to run onto those things, and I'll explain it in more detail. So let's first go with the experiment part, right? Our ML experiments. If you see here in my data folder, I have this data, customer churn data is there. And I'm going to use this for this experiment. Right now, I'm not using anything of a SageMaker. This is very simple experiment. You could have run this notebook in your local also to explain you how a very basic data science work that you do, right? So if you're going to run this, okay, there are few requirements are there. So we basically need to install the packages that are there if any packages are missing. What we can do, that's ideally we should be doing it like every time if you have any new repo or new project starting up, make sure all the packages are installed, right? So I am going to install all the packages and then just refresh or restart this kernel. So I'll just make sure that all the packages that is required is available. And that's all, right? Like you can see now, I'm not getting that error. And probably it will take some time, read the data and give me the response. And I'll not spend a lot of time in walking through through this problem, but you can go through this notebook, run this cell and understand what are the problem which we are trying to solve. And you will see here that I have this data where you will see the pattern and distribution, how many people are going to churn, no churn, distribution of the age based on the churn, total spend distribution, usage frequency. These are all EDA that we generally do before going into the modeling exercise, and that's all what we are doing. Also, you can see I'm doing some basic data pre-processing where you remove the customer ID column because of it's not any meaningful. Check if any missing value is there in the data set and you'll drop that missing value. Also, what you do, you like split your data into X and Y, right? Take your features separately, take your predicted columns separately, do the scaling of your data. If there is a numerical data, you do standard scaling. If it's categorical data, you do one hot encoder, right? Then what we are trying here is creating some categorical features that are there, right? So I'll just run this and do this feature engineering part. Now what we are doing here is like, we have created a new process data. So that we are storing as a customer churn process .csv as a separate data, as like a process data that can be used. Also, the joblib one, like the pre-processor that we have used for doing all of this pre-processing, we are storing it. And I'll tell you why it is going to be important, because when you're doing inferencing and testing, right, it will be important to have those artifacts with me. Okay. And that's all I have done, and I've stored the data. I'm checking if there is any missing value that is present in my data set or not. Like, you can do it. Can test if any missing value is there. Okay, my bad. It should be X processed. Yes. So you can check if any missing value. Yeah, no missing value is there. That's good, because you should make sure that your data is cleaner. Now what we're going to do, we're going to start our model training, and you can see here, like here I have picked up a random forest model, and I'm just trying out the accuracy of the model, try to evaluate that model, how the model is performing. So we have a good amount of data, like not very huge, but yeah, definitely you can see the training size is almost 350K. And if you run out of space anytime, right, better try to have a different compute. So you can stop the server and use a bit bigger machine. If you run out of memory anytime, like that could be the challenge you generally see. If there is anything, any server related issue or anything, that also you can check. By default, it will show you if any issue is there on your system. Let it run. Not only this, I'm going to test out the model performance, that if you are training, if you run this, you can evaluate. And that's what we're going to do. It will take some time because the data is big, right? So it will take a couple of minutes to train the model and then give you the result. Once you run it, you will see this is how my model performance is coming. I'm getting pretty good accuracy of almost 99% accuracy on my data. And what I'm doing, I'm storing all the artifacts, right? I'm doing, XGBoost and pre-processing the model that we have used and the preprocessor that I have. I'm storing these artifacts into respective folders separately. So once you run this, your basic experimentation is done. But now you can see I'm restricted in a way, right? I cannot log anything out of this. I have tried 3 different models. One is random forest, one is logistic regression, one is XGBoost, but it's not a very fair way of I have for evaluating or comparing these models. That's where we are going to use MLflow as a next thing, and experiment and run it in your notebook. But let's start with MLflow, like how we can use MLflow. So go to this and start a server of an MLflow, right? If you'll come here, you can see, right, create a tracking server. If you will start your server, by default, you can give a name. Then you need to provide an S3 part. Okay, this is already taken. I can say my MLflow experiment. And this is the path where you'll have to find the S3 location. Now, this is important. Let's go back to the S3. So this is another important service that is present. And if you see, whenever we start a new Jupyter domain, you can see that it automatically creates an S3 bucket. But if you want to use any other S3 bucket, that also you can do. Right now, if I'll go back to my IAM profile, if I'll go to my SageMaker, let me go back to the SageMaker instance that I had. And the domain, the latest domain that I have created where I'm working right now, this is the one, right? So 283, and with the same kind of name, 283, If do I have a bucket? No, maybe I have this bucket right now. I don't have a bucket at least created. So let me use this bucket, and I can use this bucket for my MLflow or ML flow work. So I can define this bucket, and yeah, that's the location. And let's create this MLflow experiment and use this. Now, what I'm using this bucket, if you see right now, nothing is present, and you can see the MLflow experiment is getting started. Now it can take more than 10-15 minutes, as it is mentioned, like it may take 20 to 25 minutes. So we just sit back and relax and just wait till that time. We will be able to use this. Till this time, what we are going to do now, if you see this MLflow experiments that we have, right, like we want to use this experiment tracking server to log our experiments. But what we have to do here, I need to provide some permission so it can access that as well, right? So another service that we are going to use here is IAM. IAM policies allow which service, which user can access what, right? So I'll come to this roles, and if I'll see here the SageMaker, this role that is there, I'll use this SageMaker role and my execution role right here. And I need to add some permissions here that I'll do. So if you go to this SageMaker execution policy, I need to update few policies here. It's only right now has S3. So let me edit this policy. And in the repo itself, I have provided you this JSON part, right, for the policies where you get more, service where you can get S3 access, even for MLflow, where you can have all the services for tracking and getting access to UI and other things. If you add this thing, you will get access to almost everything. So if you want, you can just copy paste, and that's all. Like just update it and see. It will check if there is anything breaking or not. Because what will happen if we'll come back and if we'll try to access the server, you won't be able to access the server, this MLflow one that we have just created. Right now it's creating, but if you do not provide it, you'll not be able to even access that and open that if you not provided right policies. So that's why our policies are important for you to even access. You can definitely restrict your users and create different permissions, but I am right now only working more with S3 and MLflow. That's what we are going to work. So I'm giving all the service. If you'll give next and update your policies, save changes. So our service is getting started, and this is how your MLflow will look like, right? You can see this is the same MLflow. If anyone knows MLflow, you will see the exactly same kind of window is being created, right? Here you can create prompts. Even the 3.0 has prompts, so where you can keep. See in the notebook, that's where we have, right? Like we are just installing all the packages that we have that make it true. So what we are going to do, we have checked that all the packages are installed. And then what I'm doing, I'm creating the experiment name. So you can see a kind of AutoML experiment name that I am creating. I'm just doing it data pre-processing here. So that also, if you want, you can log it, but ideally you can just should log more of a model related. If you refresh it, nothing is there because we haven't logged anything. So we have just got the data. Now you can see I'm defining different models that I want to try. So I want to try XGBoost model. I want to try light GBM model. I want to try random forest. Under this AutoML, I have random forest with this hyperparameter, gradient boosting, logistic regression, SVM, another model, right? And you can see here, all these are different configurations that I have defined. But what I'm going to do here, I'm going to, whatever the model training that you are going to run, right? You need to run this under this. And even if you want, you can do auto ML like part or auto logging part, MLflow, which will automatically log all the metrics that is there. But if you define some metrics that you want to log, let's say the metrics name and some value that you explicitly want to log, you can do that also. Let me run this. What will happen? The training will start. Now, what it is doing, AutoML will evaluate all the 6 models and will start logging that, right? Let's wait for again couple of minutes, because let this training happen, because this data is a little big, so it will take couple of minutes for it to run and start logging all these metrics slowly. Once this is done, you will see all the metrics that we have defined here, including the model name, what is the model accuracy, what is the model hyperparameters, and other things that we have defined here. All this will be available in your MLflow experiment tracking tool. Used even MLflow for tracking the server. Now let's get into how we can use SageMaker to train our model and even deploy our model. Right? For that, you go into the SageMaker folder and click on this notebook, SageMaker end-to-end. What we're doing here, we are just training a simple model using SQL Estimator. Then we're going to deploy that model, and then we're going to see how we can handle and pass our input to that endpoint and get some output. Now, interesting thing that you have to see here, right? Till now, we haven't used more of a SageMaker framework or any of SageMaker components or services till now, right? But here we are going to use everything. So the first one is the session, which we are initializing the SageMaker session. This is the execution role, as you have seen, right? I have given the IAM permission for that role. So, and this is the bucket. By default, it will pick up that bucket. If you have provided some other bucket, you can use that bucket also. Let me run this and we'll see what is the SageMaker role that we are using and what is the default bucket that it's stored. I just killed this because it was taking a lot of time, and it will come back here under this MLflow. You can see all of these experiments are getting logged, right? And a lot of different metrics are getting created, like best accuracy, ROC score, and test accuracy, test F1 score, test precision. Everything is getting stored here, right? And what you can do, you can actually evaluate your model from here. And that's how you actually can compare your model, different experiments that you have. You can compare them, evaluate them, a lot of things you can do from here. So that's pretty much the MLflow. So now you can see this is the default bucket that we are going to use. Now, second thing is upload data. Till now, we have used Jupyter Lab space for accessing the data, but in real world, you will access data from an S3 path, right? S3 bucket is the default location where you can store data, store artifacts, store model, a lot of things you use that, because there's a storage system in SageMaker. What we're doing here is we are uploading this data, right? I have this raw data that is present, even the process data part that is present, right? That we have used during the experimentation. What I'm doing, I'm uploading this part. So I'm using S3, Boro S3 to use how I can upload the data. You can go even manually, you can upload the data and do that. If I'll run this, you can see it's going to start uploading the data. So it is going to pull this data and it's going to upload the data in this bucket, and the data raw format and process data. Okay, and I get this summary is there. If you want, you can actually go back to S3 and you can check by yourself if the data is present there. This is the bucket that we have used. Under the data folder, raw, you can see under the raw, customer churn.csv is there, and under processed, customer churn process.csv is there, right? So data is there. Just now I have updated, and I can use this data now for my further analysis and training purpose. Now what we have here is the training part. You can see here what I'm using. I'm using a training.py script. Let's get into this. You can see here I have this training.py script. What this training script is doing, it loads the data, trains a random forest model, and save the trained model. If we'll go inside it, it expects some of the arguments that is there. There are some default arguments that is already there. Let's say number of estimator, maximum depth, minimum sample split, right? You can create your own. Another two most important thing is the model path directory, right? Where exactly I'm going to store the model output, and then the training part where the training data is coming from. So these are the arguments which is required for your training pipeline. Now, if you see, the important part here is you can see this is the path where it is pulling. What actually happens when the training job starts, it actually spin up a new EC2 instance. What we are going to define, I'll show that up. And it actually pulls in Docker image so that inside that container, all the data artifacts move inside the container. And that's why you know that, right? In the Docker container, the default path starts with opt, and then you have ML data, any other path that you have, right? That's what we are using this as a default path, and we are going to move our data. So if you see here, this is where I've defined different functions. Let's say load data. So if data is a CSV file that we have provided for your training part, it will load that data, it will read that data, and it will return that data. Then we are preparing the data, right? So if it's a churn column that is there, right? Because we are making this project for customer churn prediction, it is going to take that as a target variable, then divide it into X and Y, and then the training function. This is where your model training will start. So we are splitting the data into train and test. Then I'm creating a random forest classifier. Then I'm logging this, and then I'm doing model fit. So the training will happen, then some testing. How is the model accuracy coming? And then I'm returning this model. So this is a function which is doing the training. Then another function is there for saving the model. And this is the main code, which is going to execute everything. So the first one is going to load the data, then prepare your X and Y, then train your model and save your model. That's all this training.py is doing. So what is going to happen now in my training code? This is where I'm using SageMaker Estimator. So this is the SageMaker Estimator, which is the entry point is training.py, and it is picking up from here. This is the role. This is the instance type. So it will start an ML.m5.large machine. This is the framework version. So Scikit-learn framework. It depends upon, there are some latest version also available, the Pi version, and this is the hyperparameter input that I am passing. Once I'm going to run this, you can see here, I have defined this Scikit-learn estimator, and this is the training input part. This is the file where I have, so default bucket, data, and the processed file. Because I want to use the processed data, I am going to provide this training part. And once I launch this Scikit-learn estimator.fit, once I run this fit, you can see a training job has been started. You can go to the SageMaker, come under your jobs and come under your training part, and you can see that a new job just started. It is in executing status right now because it just started. So it will take almost 3-4 minutes to spin up a machine, and comes up by installing the packages, required artifacts, running your model training, and then saving your model out, right? So it will take again probably 10 to 15 minutes. It can take, depends upon how big your training pipeline is. If it's a deep learning based or it's some extensive, it can take even hours for this pipeline to run. So you can just wait for this training pipeline to get over. Once it is done, the artifacts will be generated for you. Started like our training, it has started to create a container, and then it has started taking the hyperparameters, installing packages, and then created a training script, right? And you can see that like the training is over. The training of random forest model is completed, and you can see it has even uploaded the training model. Training job is completed. If you'll go back to your training instance, you can see the job has been completed. If you go inside it, the complete logs would be there, the performance, what are the artifacts are getting generated. So it will, the mod file that is generated, it will be present in your S3 path. What are the hyperparameters that has been used, configuration, a lot of things that is important for you tracking it later on. You can find it here, and our model is generated. Okay. Now let's go to the deployment side, right? Once you have a model that is generated, you're going to use that model path, but inference.py script will do, as you know, right? For prediction, you need model and input, and maybe processing file that has been used, right? So here we're defining it, the model function, which is going to read and load the model file that is there from the S3 path. This is the input function because you are going to create an endpoint. The input can be in a JSON or a CSV format, right? So we are actually defining the schema accordingly. If the input type is coming like a JSON, it will create a data frame, and then that will be passed. If the data is coming into CSV format, it can be read directly. And this is the prediction function. Once you load the model and do the predict probability and return that probability. And the last one is the output and function that is there. These are some default functions also available. So this is your inference.py. Now, in order to create your endpoint, that's what we are running here, the scikit-learn model. And then instead of we are defining the model path where your model data is going to be there. And the inference.py is the file that is going to execute. And once we run this model.deploy, here we are defining the instance type and how many instances you want to create, and the endpoint name. What is the name of the endpoint that you really want to keep? And let's get started, right? You can see we are using the model that has been created. Okay, it is saying that endpoint name already exists, right? So let me create some new name because I would have already created endpoint with the same name, and let me create it, like give it 1, and let me run it. And you can see that customer churn endpoint 1 is getting started, like the creation of this getting started. Where you will find this, if you come here under the deployment, under the endpoint names, as I mentioned earlier, you can see that it is getting created. And this will again take a couple of minutes for spin up a machine and starting your endpoint. Meanwhile, again, you can just wait for a couple of minutes for it to come. And once it is done, you will be able to see that endpoint live in your SageMaker. Now you can see it took a couple of minutes. Let's pause the video, and you see this now endpoint is created successfully. If you'll go back to your endpoint, you can see this customer churn endpoint 1 is live, right, in service. Let's test this out. What we are going to do, we are going to run this code to test our endpoint. And you can see the first test I have done is I have passed a JSON file, and you can see I'm getting the prediction 1, right? And I'm getting the probabilities as well. And it gives you other information also, like, what is the confidence score of the prediction and other things. Same thing, I can try it out using a CSV path data, right? I'm passing a CSV file and I am returning the output. And again, I am getting this output. So you can run this code and get the output. And now you can see whenever you can give this endpoint to anyone, even anyone is going to, if you go to this endpoint, this is the URL, right? So you can, if you open source this like endpoint, and anyone can use any curl command or Python SDK or anything to give an input to this model endpoint. And once you will invoke this endpoint, the output will be available for you. The model predictions will be available for you. You have other things as well, like auto-scaling. You can define the auto-scaling, how much traffic you want. Like if you go to edit auto-scaling, you can define auto-scaling policy. Let's say if you scale, if you're getting more traffic, how many instances you want to do, how much capacity you want to keep. So it will be really useful when you're scaling out your model. So that's how you can build and deploy your model and create an end-to-end ML pipeline. Last one is to delete this endpoint, because you don't want this endpoint to be keep on running. So you can just clean up. Okay, I'm just deleting this endpoint right now. It's been commented out. So if I'll just run this, you see it will list me that this is an active endpoint that is there. And once I run this delete endpoint, you can see here it's in deleting state. And if you'll go back again, you could have done this through UI as well. And you can see it's refresh. Okay, there is no endpoint now because I just deleted. So no endpoint is there. Okay. And if I again list endpoints, you will see no endpoint is there. No active endpoints found. That's how you should be able to build a simple model and even deploy it and do the testing in. And if you want to scale it up for production, that's how it'll go. So that's it for this video. Thank you. Please like, comment, and subscribe if you love the video. Thank you.